Hi students, welcome to today's class. In the last classes, I have explained what is a differentiability and an application of differentiation. So, we have explained what is a tangent and a normal. Their equations are also I discussed. In the today's class, in the chapter applications of differentiation, so we are going to see the angle between two curves. Generally, we come across angle between two straight lines. If two straight lines are there, then if they intersect at one point P, then we can clearly say the angle between them is some theta. Whatever may be the acute angle, that angle we will treat it as a angle between the two lines L and M. But when two curves intersect each other, if two curves intersect each other, then how to define angle between two curves? If they intersect at a point, let us call it as a P and a Q. If they intersect at a P and a Q, then how to say the angle between two curves? See here, if you define this angle between these two curves like this, can you measure the angle? Can you measure the angle? So it is not possible to measure the angle. Why? Because these are in the curvature type. These are in the curvature. Curve type, then how can you measure? If they are straight lines, then we will bring a protractor and we will put the protractor there and we will start measuring 0, 10, 30, 25, 30, 45, 60. Therefore, angle is 60 degrees. Then how can you put the protractor here and measure the angle? So now the mathematicians, they define the angle between these two curves as, first identify the point of intersection of the curves. Okay. So these are the point of intersection of the curves. Okay. At the point of intersection, draw the tangent for the first curve and draw the tangent for second curve. That means what? This is the point of contact for both the tangents, but both the curves. Okay, now the angle between these two lines, the angle between the two tangents, the angle between the two tangents is defined as the angle between the curves at the point of intersection. Understand this? So the angle between the tangents is same, is defined as the angle between the curves at the point of intersection. Understand? So like that they define. See here, in the straight lines, if this angle is equal to 90 degrees, that means if these two lines are perpendicular, theta is equal to 90 degrees, if these two lines are perpendicular, then we call them as, if the angle is 90 degrees, then we call them as perpendicular, we call it as. But whereas, if the angle between these two tangents is 90 degrees, if the angle between these two tangents is 90 degrees, then we say that these two curves are intersect orthogonally. Orthogonally. Here perpendicularly. Here perpendicularly. Here orthogonally. Here perpendicularly. Understand this? Both concepts are same. If the straight lines are there, we call them as a perpendicularly. If the curves are there, we call them as orthogonally. So what is meant by orthogonally? If the angle between two curves is 90 degrees, then we say that the two curves intersect orthogonally. Okay, now vice versa. Okay, so now given the equations of two curves, so here the equation of first curve is given f1x, equation of second curve is given f2x. Then how to find out the angle between the two curves is, let us see the formula. So let us go back to the chapter straight line. Let us go back to the chapter straight line. Let us see there are two straight lines are there. Let theta be the angle between them. The slope of the first line is m1. Let the slope of the second line is m2, m1 and m2. Then if theta is the angle between them, then we have tan theta is equal to modulus of m1 minus m2 by 1 plus m1 into m2. Tan theta is equal to modulus of m1 minus m2 upon 1 plus m1 into m2. That formula we have in the straight lines. So here also we will apply the same concept. Let us take two straight lines. They are intersecting at a point P. Let there be a two tangents. One is for the first curve, n is for the second curve. It is the theta is the angle between them. To find the angle between the two curves, first thing what we have to do is, first we have to solve the equations of these two curves. Y is equal to y1 is equal to f1 of x, y2 is equal to f2 of x. These two curve equations, you solve them, then we will find the point of intersection. After finding the point of intersection, we know how to find out the slope of the first curve. So this is given by, let this point of intersection is x1 y1. So this is equal to dy1 by dx. So you substitute x1 y1. The slope of the second line m2 is, find the derivative of the second function and substitute the derivative of the second curve and substitute in the point of intersection. In that we will get m2. Therefore the same formula we will apply. Tan theta is equal to modulus of m1 minus m2 by 1 plus m1 into m2. Understand this? m1 into m2. Okay, right. So first we have to find out the point of intersection of the two curves. We have to solve those two equations. Solving equations means we have different methods we will apply. Sometimes we will apply trial and error method. Sometimes we will get a quadratic equations like that. So we will see in the while doing the problems. Okay. So here after solving, compulsory we have to find the point of intersection where we have to find out the angle between the curves. After finding, first find the derivative of the first function, find the derivative of the second function, substitute those values in those equations, substitute those values in that dy by dx, we will get m1 and m2. Therefore tan theta is equal to modulus of m1 minus m2 upon 1 plus m1 m2. So why you have to keep modulus means, generally we will take a acute angle as the angle between the two curves. Now here a very important note point. What is the note point means? First note point. If the curve intersects more than 2 points, sometimes there are some curves will be there, they are intersecting at more than 2 points, here. So more than 2 points they are intersecting, more than 1 point they are intersecting. Then is it necessary to find the angle between the curves means at each and everywhere you have to find a? No need to find out. So you find the angle between the curves at any one point of intersection, then you will be that will be the same for every point of intersection. Okay na? So no need to find out everywhere. That is the first note point. The second note point is, the angle between the tangents at the point of intersection is same as, if you find out the normal, for example this is the first tangent, for this is the normal, and for second tangent this is the normal. This angle is also same. That means angle between the tangents is same as angle between the normals at the point of intersection. So observe here, angle between the tangents is same as angle between the normals at the point of intersection. Okay now, right. So what are the two important points I have explained? The first important note point is, if the two curves intersect at more than 1 point, no need to find out at each and every point angle between the curves. If you find out at only 1 point, that is enough. What the second note point where here, the angle between the tangents is same as angle between the normals at the point of contact. And one more thing, very important thing, if the curves are orthogonal. If the curves are orthogonal, then we have curves are orthogonal. That means what? Orthogonal means what? The angle between them is 90 degrees. So automatically we have m1 into m2 is equal to -1. The product of the slopes, that means dy by dx x1 into y, x1 y1 after substitution. Here dy by dx x2 y2 after substitution. So multiply, if you multiply just once you do solving the angle between, so once you check that m1 into m2 value is minus 1 or not. If it is not minus 1, then you go for this formula. If it is minus 1, then and there only you declare that the angle between the two curves is 90 degrees. The curves intersect each other orthogonally. Okay. So, this is the theoretical part based on angle between two curves. Let us see some problems based on this. Okay. Welcome back here. Find the angle between the curves f of x is equal to 2 power x times log x to the base e and g of x is equal to x to the power of 2x minus 1. There are two curves are there. Then how to find out the angle between them? Let these two curves intersect at the point x1 comma y1. x1 comma y1. Then we have f of x1 is equal to 2 times x1 log of x1 to the base e. G of x1 is equal to x1 to the power of 2x1 minus 1. Understand this? At the point of intersection, if you want to solve it, this is also y is equal to, this also y is equal to actually. So, if you want to solve it, so solving the equation 1 and equation 2. So, what you will get 2 to the power of x1 into log x1 to the base e, x1 to the power of 2x1 minus 1. So, this you have to solve it. Now, the question arises again straight. Then how to solve it? This side is a logarithmic function, that is some exponential function. This also one exponential function is 2 power x1. So, when this type of situation arises, the one and only one option is trial and error method. Trial and error method. Let us take x1 is equal to 1. Let us see what happens. x1 is equal to 1. So, log of x1, 2 to the power of x1 into log of x1 to the base e is equal to how much? 0. We are getting here 0 we are getting. Log x1, 2 to the power of x1, 2 to the power of 1 is 2. 2 into 0 is 0. Total value is we are getting 0. Here also in place of x1 substitute 1, 1 to the power of 2 into 1, 1 to the power of 2, 1, 1 minus 1. Here also you are getting 0. So, 0 is equal to 0 you are getting. So, you can get x1 value as 1. Therefore, y1 value you are getting 0. Therefore, point of intersection is 1 comma 0. Point of intersection is 1 comma 0. So, like that you have to guess the answer. Understand this? Okay, for this particular problem. But there are other problems are there, we can easily solve those equations. But for this situation it came, so just simply trial and error method. Now, what you have to do? First to find out the derivative of the first function. So, therefore, dy by, this is the first function I am taking, dy by dx is equal to, so 2 power x into log x to the base e, u into v formula, that is 2 power x into log x means 1 by x plus log x to the base e into 2 power x derivative a power x, that means 2 power x into log 2 to the base e. Okay, now substitute 1 comma 0, we will get the slope of the tangent for the first curve. So, wherever x is there, substitute 1, 2 power 1, 1 by 1, that is equal to 2, plus here log 1 to the base e 0, 0 into this is also a finite value 0, this you are getting 2. Let us find the derivative of g of x is equal to x to the power of 2x minus 1 derivative is x to the power of 2x into 2x into 1 by x plus 2 times log x to the base e. So, here x can get cancelled. At x is equal to 0, x is equal to 1, if you substitute 1 to the power of 1, here 2, this 0, this m2 value also you are getting 2, m2 value also you are getting 2. Therefore, we are getting m1 value 2, m2 value 2, both are same. Therefore, in this situation, the angle between the curves is equal to 0 degrees. The angle between the curves is equal to 0 degrees. I hope that you understand this solution. Let us move to next problem. Welcome to this second problem. Find the angle between the curves y square is equal to 4x and y is equal to e power minus x by 2. Okay. So, why I have selected this problem is, see here, y square is equal to 4x and the curve equation y is equal to e power minus x by 2. Generally students, they start solving the equations. But sometimes without solving the equation, that means already we told that the point of intersection is, we have to find out the point of intersection before finding the angle between the two lines. So, without finding the angle point of intersection also, sometimes the problems will come. So, just like this is one example. Let the point of intersection be x1 comma y1. Let the point of intersection be x1 comma y1. Therefore, what we will have? So, 4x1 at the point of intersection. y1 is equal to e power x1 e power minus x1 by 2. So, at the point of intersection, that point of intersection will satisfy for both the equations. Find out the dy by dx for this. So, this is a 2y into dy by dx is equal to 4. So, from this dy by dx is equal to how much? 2 by y. Dy by dx is equal to 1s or 2 2s are 2 by y. What is the slope of the tangent? 2 by y1. 2 by y1. Put it like that. Coming to here, so find the derivative of this function dy by dx. So, therefore, dy by dx is equal to, first e power x derivative, e power minus x by 2 into minus x by 2 derivative minus 1 by 2. Okay, now e power minus x by 2 is nothing but y. E power minus x nothing but y. That means minus y by 2 dy by dx. Then what is the slope? Minus y1 by 2. You have to substitute this point, no? Minus y1 by 2. What do you observe? m1 value is 2 by y1. m2 value is, that means find out m1 into m2. This is a 2 by y1. 2 by y1. This value is minus y1 by 2. Both will cancel. You will remains with m1 into m2 is equal to minus 1. Hence, the two curves are orthogonal. Angle between them is equal to how much? 90 degrees. Okay, now. So, why I have selected this problem is, generally students they will struggle hard for finding the point of intersection between the two curves. So, that means they will equal. So, y square means y is equal to plus or minus 2 root x, again they will equal these two. So, it is something difficult to get the x and y values separately. Okay. So, here what you have to do, let us suppose that point of intersection is x1 y1, find dy by dx, substitute x1 by 1. Second curve dy by dx, substitute x1 by 1. If you observe m1, m2, they are, so you approach this method also in the competitive examinations. So, you think in a logical way, okay, logical way. Why? Because immediately whenever such type of curves are given, so it is somewhat either trial and error method also you have to apply. Otherwise, it is something difficult to find the point of intersection. Then suppose x1, y1 is a point of intersection, and then proceed. Definitely you will get the answer. Okay, now. So, I hope that you understand this solution. Let us move to next problem. Welcome back to this problem. Find the values of a if the curves x square by a square plus y square by 4 is equal to 1 and y square is equal to 16 is cut orthogonally. So, if both the things are cut orthogonally, then what is the value of a? So, here a is there. Then how to do find out? So, let their point of intersection be x1 and y1. So, no need to find out any point of intersection here. So, directly we can let us call them as a point of intersection as a x1 y1. Find the derivative of this function. So, this is equal to 2x by a square. This is a 2y into dy by dx by 4 is equal to 0. Okay, now. So, here 2, 2, 0 you can cancel here, x by a square plus y by 4 into, you can call it as a m, no problem, this dy by dx. Let us substitute that, let us suppose that we substituted x1 y1 in the dy by dx. Okay, now. So, from this y by 4 into m is equal to minus x by a square. So m1 we call it as a minus 4x by a square, minus 4x by y a square. So this is equal to m1. m1 is equal to how much? Minus 4x by y a square. Let us take y square is equal to 16x. Y square is equal to 16x. So this is a 2y into dy by dx is equal to 16. So therefore dy by dx is equal to 2 by y. 2 1s are 2 8s are 2 8s are 8 by y. Okay now, right. So therefore our m2 is equal to 8 by y. 8 by y. Okay. Now these two are cut orthogonally. Therefore we have m1 into m2 is equal to minus 1. What is m1? So this is equal to minus 4x by ya square into what is m2? 8 by y is equal to minus 1. Minus 4x by this is a minus 4x by ya square into m2 value is 8 by y. Is there any more cancellations? Any more cancellations? Let us see here. Y square value is equal to how much? 16x. Let us substitute y square value is equal to 16x. So this is equal to minus and minus both can cancel. Both can cancel. 4 8s are 32x. 32x by a square into y into y square. Y square means how much? 16x is equal to 1. Okay now. So here x cancel. 16 1s are 16 2s are. A square is equal to 2. Therefore a is equal to plus or minus root 2. A is equal to plus or minus root 2. Of course here a square value positive, but a can be plus or minus root 2. Okay. So that is the answer. Here from this problem, what do you observe? What is the inference that we will get? The inference is, here we did not find any point of intersection. This is the short trick methods that you have to apply for your competitive examinations. So we did not find any point of intersection. So we have not supposed also x1, y1. So just we started m1, we call it as a m2 and we multiplied, we got the answer. So this is the short trick methods that you have to apply for your examinations. Okay. So I hope that you enjoyed today's class, and there are some more problems. Tomorrow's class I will stand before you. So until then, all the best.